Thank you so much for taking the time. I appreciate it.
Yeah, man. Appreciate you sending out the invite.
Yeah, of course. So, what kind of got you into the Carolina Bays and what's your background?
Well, I'm a secondary science educator. I teach Earth systems and environmental science
Hmm.
in coastal Georgia, and I've been doing it for about almost 25 years now.
Wow.
Yeah, it's been a while. And actually, when I was going to school, my undergraduate for education, I was taking like every geology class that was offered at the school that I was going to, which was Valdosta State University. And one of the field trips we took was to a place called Grand Bay, and it was a neat place. It's a huge swamp and has a, boardwalk that goes out into the middle of this big circular swamp. And there's a 100-foot tower that you can climb up to the top and just see the whole thing. And there's alligators and there's pitcher plants and all the swamp life that you would imagine.
Hmm.
But what I found was interesting was how circular it was in shape. And I can remember the professor said this was a field trip. So I was asking the professor, what's going on here? How did this form such a circular shape? And he corrected me and said that it wasn't a circle, that it's more of an ellipse, and it was something known as a Carolina Bay, and that they actually stretch all the way across South Georgia into South Carolina, North Carolina, all the way up into almost New York. And I was like, really? That's pretty amazing. Where Valdosta State University is, we have sinkholes, and that's what I thought it was. I thought that it was a sinkhole that had filled in with peat and became this big swamp.
Hmm.
But again, he corrected me and told me that no, that was a Carolina Bay. And at the time, he told me that this huge swamp was created by wind and water processes. That during the last ice age, strong winds were coming off of the glaciers, and they were creating ponded water to circulate in such a way that these ellipses formed. And I was like, okay, that's pretty neat, until you actually see them and see how many there are all across the southeast, and they all have like raised sandy rims. They all have a orientation, which means that they're all kind of pointed in the same direction. And that's what I found fascinating. So I started looking up the stuff online, and this was back in 2000. So
Hmm.
we didn't really have, like, the internet was really just starting.
Yeah.
And so I think I asked Jeeves, what the heck are these Carolina Bays? And it actually popped up a website that was hosted. It was actually called GeorgeHoward.com, and George Howard is now one of the members of the Comet Research Group, and he's basically the founder of these Carolina Bays.
Wow.
But he had made a comment that it could have been caused by an impact, and basically an impact into the Laurentide ice sheet that may have created these as secondary effects. And again, this was back in the year 2000, and I thought that was fascinating.
Hmm.
And that's really what kicked it off for me. Here we are 25 years later, and we still don't have answers. There's still a mystery. Even the professor, 25 years ago, he brought up the cosmic impact, but kind of brushed it to the side real quick, and went with that wind and water explanation for the Carolina Bays. But he did say that it was a mystery, and in my I was like 21 or something like that at the time, and that mystery kind of popped a fuse up there, and I was like, man, we gotta solve this one. This is something that we can get into. And so here we are now today. Throughout my process of as being a secondary science teacher, I've got a couple master's degrees, and the most recent master's degree I got in 2015, which is in geoscience from Mississippi State University. And once I got that, it was time to kind of start cracking down on some of this stuff. And ironically, that was around the same time that Randall Carlson was on the Joe Rogan show, the Joe Rogan podcast. And I just finished my master's degree, and so we kind of started putting those things together, and started putting out these presentations, and they've gotten a lot of attention, but we still don't have we still don't have a an answer to the mystery. It's still a mystery, and I think we're getting there, but we're not there yet. So we'll see.
Yeah, it's fascinating. So what does like mainstream academia say about it, or what is their like main theory, if they have one?
Yeah, so the most academically accepted hypothesis for the Carolina Bays are that they are Aeolian and Lacustrian formations, which basically means that they are strong winds coming off. It's called katabatic winds coming off of the last ice sheet
Hmm.
that would have been blowing across the East Coast, very strong winds, and all of the Carolina Bays would have had to have been ponds. And those strong winds would have circulated the pond water in just a way that they created these elliptical shapes. And then they just stopped. Basically, they said that they happened at a couple different times during the last major glaciation, which is, around 100,000 years or so. But they basically said that they swirled these ponds around in just a way that they became elliptical in shape, and then they just stopped and they froze in time, and that doesn't make a lot of sense. Geologically, it doesn't make a lot of sense, and we've done a lot over the past couple of years to try to kind of point those things out that geologically don't make sense,
Hmm.
and just in the hopes that we can reopen this case and we can get some fresh eyes on it and to actually go out there and solve it. I've been in it now heavy, like I said, 2015 to spend 10 years. And this was, in my opinion, it was low hanging fruit. This is something that we should be able to get out there. We'll solve it, and we'll move on from there. I actually have a YouTube channel called The Dabbler's Den, and a dabbler is somebody who constantly goes out and tries new things, and is always finding new hobbies and getting into something really really heavy and then moving on to something else. And I've been kind of stuck in these Carolina Bays for 10 years now. I figured I'd be done with this and we'd move on really quick. And I found that the scientific community is really stubborn, and they, it's kind of met a couple brick walls. And
Why do you think that is?
it's just, I don't know, to be honest with you. We'll go over my presentation, and,
Okay.
and we'll kind of talk about some of those things. But really, when you see it and it's broken down, it's a hard question to answer. Why is it
Hmm.
like that? I don't know. I wish I could tell you.
I'm surprised, like since it is such a mystery, how people could be so kind of stubborn towards one theory, I
Right, right,
suppose.
and so definite about it. And it's like, no, when you look at it and you take a step back, it doesn't make sense. It really doesn't make scientifically. It doesn't make
Especially that
sense.
one, yeah.
Yeah, yeah. And so from the very beginning, and that's actually why I got involved when I did, as a secondary science educator. Following the scientific process is important to me. It is
Hmm.
it's basically like the foundation of what I teach, with everything.
Yeah.
And when I can't honestly talk about Carolina Bays and following that scientific process to their conclusion, that's a problem. And that's kind of where we start with this. This whole story is really with the scientific method and just following the scientific method. And there's been a breakdown in that
Yeah.
for the Carolina Bays for sure. Let's take a look at a couple slides. We don't have to go through the whole thing,
Hmm.
but I've spoken about this a couple times at the Cosmic Summit. Basically, we've had three of them so far, and I've spoken about Carolina Bays for each year so far, talking about different topics. I've been on a couple different podcasts and things like that. So this is really kind of a collaboration of the talks that I've given to live audiences
Hmm.
in the past. And yeah, and just from the very beginning slide, can you see the slide?
Oh yeah,
Is it
the
there?
latter. Yeah. Hmm.
Yeah, yeah, yeah. So just from the opening, what we're looking at is colorized lidar, and that's the ground of South Carolina using a type of lidar that shows elevation. That's what the colors represent. They represent a difference of elevation as we're going up and down, and the place is just completely speckled with these elliptical shaped depressions. And that's what we're going to be talking about are those Carolina Bays.
Yeah.
But like I said, to me, it's a breakdown of the scientific process. That's a real problem. It was actually Sir, what's his name, Francis Bacon, who was one of the first people that put all this down in writing on using the fine scientific method, which is ironic because I
Oh
was
wow.
I was going through some of your back catalog, and
Yeah.
you have an episode about Sir Francis Bacon.
Yeah, I'm
I
fascinated,
had
man.
I haven't gone down the rabbit hole of him being Shakespeare, so I
Yeah.
I
It's
have to I have
interesting, yeah, for
I'll be
sure.
going down that rabbit hole later, finishing that one.
Yeah, yeah, man. It's another one that's kind of fascinating when you kind of
Yeah,
dive
yeah.
deep.
Yeah. So, but anyways, he was one of the first people that kind of put together, the processes of science that every good scientist should go through these steps.
Hmm.
And what I find interesting is it's something that we do all the time anyways. Any decision that we ever have to make, you're a songwriter, any song that you've ever written, you've gone through all of these steps, trying to form a conclusion, a good song.
Hmm.
And we start off with the problem. I always use the example of like choosing breakfast, to my students,
Hmm.
something that we're all familiar with. And I go through the steps of them choosing, a brick of shredded wheat versus, shredded wheat versus having like a Texas-sized breakfast over there. But we go through the whole step. You start with a problem, you gather information, you form the hypothesis, you test it, you analyze it, and then you draw your conclusion. And a lot of my students think that that's it, right? That once they have drawn a conclusion, we're good. But that's not really what has to happen. It tends to have to go back up to if you found your conclusion to be true or good, then you need to test it again. You need to have other people test it. You need to, make sure that it's replicable and you are accounting for all your variables and all that kind of stuff.
Hmm.
If it's found to be false, then you go up and you start again. You form a new hypothesis and you go through those steps and until you finally, draw a good, solid conclusion. And when it comes to the Carolina Bays, I don't think that happened. I think that there were a lot of assumptions, and those assumptions have been used to form false conclusions. And then they just went with it and they never went back to retesting it or they never went back to forming new hypotheses or
Yeah.
it just kind of ended there with the pitchfork saying this is how it is, this is science now, and I have a big problem with that.
Yeah.
And we see it a lot in science today. We see it a lot in certain aspects of science where if we're not going through the simple steps of the scientific process, then something's wrong, and we have to go back and reevaluate what those are.
Hmm.
So when it comes to the Carolina Bays, they do have very unique characteristics that make them special. They do have elliptical geometry. And when I say that they have elliptical geometry, like that's a mathematical term, that they are mathematical ellipses. There's a couple examples there on that page, and you can see they all have a perfect elliptical shape to them. Not all of them do. You do have some that are, changed over time due to erosion and the rivers cut through them and stuff. And but there are way too many of them that are perfectly shaped to be gradual, to be something that happened by wind and water processes. They
Yeah.
also all have raised rims, and they have that orientation that actually points back to the Great Lakes. And that's kind of an important part of this story is, they're kind of all pointing like a bunch of tattling third graders at the cause of what formed them.
Yeah.
And on top of that, they're not just found on the East Coast. They're not just found in the Carolinas. We also find a set of them 1,800 kilometers in the other direction in Nebraska, Kansas. We find some in very northern part of Texas. You can find a couple of them. We keep
Man.
finding more like in Alabama. They pretty much go in a radial pattern away from the Great Lakes region all the way around, and it's pretty fascinating. They stop once you get to the areas that were covered under ice caps during the last glaciation cycle. They do go by many names. Carolina Bays happens to be the term that's most familiar to people because there's so many of them found in the Carolinas. But I know you're from Maryland. They have Maryland basins up there. The Delmarva basins or Delmarva bays.
Hmm.
The Native Americans used them forever. This is where they found a lot of their waterfowl. They set their camps up on those raised sandy rims, kept them out of the swamps. They called them Pocosins, which actually means swamp on a hill, which is pretty fascinating.
Yeah.
And then, like I mentioned, the Nebraska and Kansas rainwater basins, all the way on the other side of the country, in the Midwest, we find these same elliptical shapes pointing back to the same spot that all of the Carolina Bays and Nebraska, and the Delmarva and Maryland basins are pointing. So again, there's this tells the whole story, and it's just not being accounted for so far. We first kind of got our first good look at these Carolina Bays, which is why they kind of been stuck with that term since like really the 1930s. It was this is a black and white photograph.
Hmm.
It's actually a mosaic of photographs that were taken during a survey of the Myrtle Beach area. And that
Oh, dang. Yeah.
this went in the newspaper. Everybody was like, "Holy cow, look at this!" Their first instinct was that these were meteor craters. That these were pop marks from meteors at some time in the past, and everybody and their grandmother went out there looking for these meteorites, but they didn't find any, and that's really kind of what kicked off this whole confusion with what these Carolina Bays are.
Hmm.
Basically, it's a discussion or debate over terrestrialism or uniformitarianism versus a cosmic impact, or was it caused by a catastrophic event? And that goes back hundreds of years. Really, when you think of like the Charles Darwin story and the Sir Francis Bacon and all that, it's really a debate against whether or not things happen very suddenly or if they happen really slowly over a long period of time. And one of the reasons why uniformitarianism became such a popular hypothesis to explain away natural events is because it kind of went away from that biblical explanation for things. And that's what they were kind of trying to do then, was
Hmm.
try to remove a lot of the Bible from the science and things like that. We have Noah's flood and all those amazing things, fire and brimstone falling from the sky and cities disappearing. And, scientifically, they were trying to explain that stuff away with gradual processes and trying to get away from those very sudden catastrophic events.
Hmm.
And here we are in 2025, and it's still a topic. It's still something we're talking
Yeah.
about, you know? So that's really, what it comes down to. Now, like I said, it is still a mystery. So, really we have to use our current technology. Back in the 1930s when they were literally first taking flight and taking pictures with camera equipment that they had at the time, and then literally pasting those pictures together to make a mosaic. When you don't have a lot of information, your hypotheses can vary. You can have all kinds of different hypotheses for what formed these Carolina Bays.
Hmm.
And that's what kind of happened, since the 1930s for about 100 years, like anything under the sun that could be a possibility has been hypothesized, and they've gone through the steps of the scientific method. And this is just a list of things that have been hypotheses, like actual hypotheses in the past. Everything from spring basins down to giant fish nests, which because they kind of look like cichlid nests, but they're huge, they're gigantic.
Yeah.
So it has actually been hypothesized that they were whales nesting, and it's like, well, that doesn't make a lot of sense. Come on. Giant beaver ponds is another one. They would that someone has hypothesized that all of these were giant beaver ponds at one time, and that's where the wind and water comes in. And so there's a lot of different hypotheses that have come about. But like I said, right now the academically accepted hypothesis is that katabatic winds blew out of the Laurentide ice sheet, and they turned the ponds that were there into these Carolina Bays. But today we have better technology. Now we have things like Google Earth, where we can get onto Google Earth. We can, basically we have satellites now. We've gone from taking pictures from cameras and literally having to glue them to poster boards to being able to, investigate these things from our computer desks, using Google Earth.
Hmm.
And it's pretty fascinating. We can pretty much see the entire planet today from our chairs, or our cell phones. You know, we can just pull up a cell phone and look up anywhere we want on planet Earth. And it's pretty fascinating. And then even more recently, we started to take USGS LiDAR and being able to make it compatible with Google Earth, which is something that Michael Davies has done. We'll talk about Michael here in a little bit because he's a has a big part in this story. But he has actually made a Carolina-based survey, which is now the Ovoid Basin Survey, where he has taken USGS LiDAR data and made it accessible on Google Earth. You can just go to centos.org and download his program to pull up Google Earth with the LiDAR, and it's a clickable thing. You just click it, and all of a sudden, the entire all the like uh, like the forests and the houses and things like that just disappear, and what you're seeing is the floor of the ground itself. And
Dang.
he's paired it with a color palette that goes like from one color. Next time you see that color, it's 10 meters above it. So it's basically combining a topographic map with the lidar, which is pretty helpful
Yeah.
in my opinion. Where it really helps is when we start to look at other parts of the coastal plain. And I'm showing a picture of a Google Earth image of a area close to Tatum, South Carolina. And just looking at Google Earth, it just looks like any place else on Google Earth. You see lots of farms, you see some roads, but really, when you click on the lidar, it makes the whole area pop out, and you see all the elliptical depressions that are completely covering the this portion of South Carolina, and it's pretty much everywhere. I mean,
Holy hell.
there
Yeah.
there's very
That's
few places.
insane.
Yeah, yeah. I'll go back so we can make the comparison again. I know that a lot of your audience is listening, but if we are able to put this on YouTube and
Hmm.
visually see it, it is kind of jaw dropping. You start to
Yeah.
see all of a sudden everything else is removed. You can still see where the highways were. You still see where the town was, but you're just seeing the ground. And that colorized lidar really helps make these images pop. And again, you see there's some that are overlapping. How can wind and water create this? That's
Yeah.
that's the part that gets me is how could this happen if these were all ponds? And over time, every single one of these ponds was swirled in the exact same way to form the exact same shape. That's to me, that's impossible. And I say that as kind of a hard end, like
Yeah.
impossible. Like it can't happen. That if it were to ever happen in any other situation, like we would just be completely perplexed. But here they're just like, whatever. No, it's just the wind and water. This is what happened. It's just what happens.
Yeah, to get the
So
same shape pointed in the same direction like that,
exactly
that'd
over
be
and over and over
some of them
and
are like
over and over and
overlapped.
over. Yeah. Yeah. And
So
there's
how
like
many?
70,000 of these things.
Yeah, that's what I was about to ask. 70,000, same shape,
70,000.
little bit
Yeah.
different
Yeah.
scale each, but I mean, man, it's
Yeah.
very
And there's probably,
consistent.
there's, is exactly. And there's probably a lot more than that. Because when you really start to look at this, you see like areas in the upper left-hand corner where there's just dimples. There's just like very subtle differences. You wouldn't even see them on the ground, but when you click on that lidar, it's there.
Hmm.
Those are there, and they're the same exact shape, same exact orientation. How could that be possible from gradualistic explanation? So. And then, like I said, this halfway across the country, we have the Nebraska and rainwater basins. And, you can really see how much of this area is all just farmland. As far as have you driven through Nebraska before?
I don't believe so.
It's
No.
like, well, it's kind of like driving through Texas. It's like the
Pretty
same
flat.
scenery. Yeah, it's flat as far as you can see, and you're just driving and driving, and it
Yeah.
never ends. Farm field after farm field here in this case, and but when you click on that lidar, bam, you just see all of these elliptical shaped depressions, and these are ellipses. Like I said, there are some that are subtly different, and we'll discuss those here in a little bit. But
Hmm.
overall, the same shape, the same orientation. They actually point right back to the same spot on the map. They crisscross over Michigan. Actually, it's a little bit west of Michigan, but if you adjust for the Coriolis effect and hang time and things like that, it just sets it right up over Michigan. I don't see why an impact into an ice sheet over Michigan at some time in the past couldn't be a plausible explanation. And I think it was a very good plausible explanation. This image is a mosaic that I put together to show the Carolina Bays and the Nebraska rainwater basins,
Hmm.
all pointing to the same location. And one of the fascinating things, and one of the things that geologists get really uncomfortable about, is that the location where they all happen to crisscross is like a perfect ringed bullseye pattern of bedrock. The Michigan Basin is a ringed basin where every single one of these is pointing to. Now, if you ask a Michigan geologist, they'll tell you that this basin formed over millions and millions and millions of years. And slowly, when the seas were there, the shallow seas that form the sandstones that make up the Michigan Basin, which are like super old, like they go all the way back to the Carboniferous. They're like hundreds of millions of years old, and but they were being formed as this area was slowly sinking, and that's how the basins formed that ring shape. But that kind of goes against some basic geologic principles of like lateral horizontality and continuity, and there's geologic principles that goes against. And
Hmm.
I think that the Michigan basin probably happened pretty suddenly, but there was a couple miles of ice on top of it when these Carolina bays were formed. And I think that there was a primary impact into Michigan, into that ice, and it was the secondary ejecta that was launched from that location that came crashing back down to create these elliptical shaped depressions, secondary depressions.
Wow.
Do you have any questions yet?
Yeah, here in a second, but yeah, I'm just taking in all that information. That is insane when
Yeah,
you kind of
yeah,
look at it like that, kind
yep,
of spread across Nebraska
yeah.
and the Northeast. Holy
Yeah,
cow.
and I'll also point out too, there's a paper. It's kind of controversial paper, but there has been gravitational anomaly studies done in this area of Michigan, and the gravitational anomaly almost matches perfectly to the Chicxulub crater, the gravitational anomaly of the Chicxulub crater, which is the impact that took out the dinosaurs, which
Damn.
was 65 million years ago in the Yucatan Peninsula, where they found the cenotes, which were formed like this half of an arc, and they they determined that that was actually the rim of a crater that formed 65 million years ago, the one that took out the dinosaurs. And in fact, the story is kind of similar
Hmm.
between the Carolina Bays and that Michigan, or the impact that took out the dinosaurs. But it was a tremendous amount of time difference, between the two. But things
Yeah.
like having a gravitational anomaly that's very similar, that says a lot. That this very well could have been a big deal, a major impact into the ice cap over Michigan at some time in the past, and we're not quite. That's still kind of a debatable topic about when they might have happened.
Yeah, what's kind of the time frame on that? And that would be like shards of ice coming raining down on the Northeast and in Nebraska.
Yeah, yeah, yeah. Yep. Yeah. In fact, I have a picture here. This was just a huge chunk of ice that fell off of an airplane. But you can see you can see almost see this elliptical shaped depression that formed from the ice chunk as it landed into the ground, and then all the bits and pieces of ice that have crashed down around it as well.
Mhm.
Yeah, I think that's what happened. Now there are two time frames. The Younger Dryas time frame is one that is really popular. However, I don't think that's when it actually could have happened. I used to think that that's when it could have happened, but
Mhm.
now I've been forced to push that timeline back because of the scientific process, because of evidence that I've come up with, and some others have strongly suggested in the past. And I have to remove the Younger Dryas as a possible timeline. But we'll still talk about it because actually
Yeah.
my one of my research partners, Antonio Zamora, he still thinks that this was a Younger Dryas event. And we actually just published a paper this summer on this topic, basically focusing on the elliptical shape that mathematically elliptical shape that most of these Carolina bays form and the Nebraska rainwater basins form. And basically, what we did was we found a protocol to kind of prove that these things were elliptical in nature. They're not just ovals. They're not just circles. They're like mathematically elliptical, which implies that they could be conic sections. That this is energy or actually a physical object entering unconsolidated sediment that created these elliptical shapes over and over and over again.
Yeah.
Yeah, yeah. So that's what our paper is about. And basically, like I said, this is the actual using the least squares method for proving these Carolina bays. We just basically go in and we plot these points all around the inside of the rim, like the actual where the bottom of the Carolina Bay meets the rim itself, and
Hmm.
then we just fit it to an ellipse, and it gives us a percent error. And you can see here the fitting error of this one is like 1.32%. It's like super minor. This is like industrial precision for
Yeah.
for for these natural processes that are supposedly created by wind and water. Again, to me, that's just ridiculous. This is the paper that we published. It was interpreting the geomorphology of Carolina Bays as secondary impact structures. So
That's cool.
basically, I was getting really tired of being ignored, and I figured, well, then let's put it down in a language that researchers should understand, and let's go and get it on in writing and publish it. In a peer-reviewed journal of. I mean, it was in the Journal of Environmental and Earth Sciences, and I went through the whole peer review process, which was rigorous and kind of a pain. It took us 8 months to get this thing finally published, but we got
Damn.
it. So yeah, yeah, that was a big thing. So yeah, in my eyes, this can only be the creation of a secondary impact. So that really comes down to like when could it have formed? And we have like two main possibilities, and they're separated by like almost 800,000 years.
Holy shit.
So yeah, yeah, yeah. So what we were looking at here is actually a timeline of Marine Corps data that we've been able to collect from the Greenland and the Antarctic ice cores, and we are able to go back in time and pull out marine oxygen isotopes from the ice cores, and that gives us temperature data. And what we've been able to use that for is kind of confirming that we go in and out of ice ages. Like this last glaciation cycle was just the last time that we went in and out of our current ice age. Like we went in and out of that glaciation cycle. The last interglacial was 125,000 years ago at this MIS 5E, which is like the peak here. And then
Hmm.
the very deepest part of our last ice age was around 20,000 years ago, which is at the bottom. I don't know if you can see my arrow or not, but
Yeah, I can see it.
okay, okay. So again, one of the possibilities is that this was a Younger Dryas event, which is interesting because we are finding good solid evidence of there being an impact 12,900 years ago.
Where do they
That's being
think that is? Sorry.
what's that?
Sorry to interrupt. Oh, yeah, I was just
No,
asking,
it's
where
fine.
do they think that impact could have taken place?
So right now, what's they okay, so hold on.
My bad if that's a dumb question.
No, no, no. It's actually a really good question because they don't know. They don't have
I
an
got
impact
you.
site, right? There's not a craters anywhere,
Hmm.
and so that makes it a really good question. Well, because we're finding impact evidence, we're finding proxy of an impact happening 12,900 years ago, but we're not finding any big craters that happened as early as 13,000 years ago, and that's kind of
Hmm.
an important part too. A lot of people have a hard time understanding geologic time. Like we have a hard enough time understanding our own history of like you know, I don't even know my like great great grandparents' names,
Yeah,
and
that's a good point. I mean, even
right,
going back a couple hundred years, it gets very dicey, man.
right, right. And so we're talking
Francis
about,
Bacon. I mean, bring up Francis Bacon. Nobody knows.
yeah.
Yeah, sorry.
So, and we're talking, we're talking thousands of years. And
Hmm.
so we have a hard time understanding that, the
Yeah,
time of like Jesus 2,000 years ago versus the time of like cavemen 10,000 years ago, or even the Egyptian timeline, that
yeah,
was around 5,000 years ago. Um, you know, that's where it's all so fuzzy. Like we just don't have a hard time understanding just our own history. So when you start looking at geologic timelines, hundreds of thousands of years, then it gets really kind of like,
yeah,
oh man, what are we talking about now? So something very catastrophic that would have happened 13,000 years ago seems like something that we would have a ton of evidence for, but we really don't. We are just now finding like the proxy evidence of impacts, which is, I talked about the Chicxulub crater and the dinosaur killer. That was 65 million years ago, and
damn.
it wasn't until like the mid 90s that was accepted as, oh yeah, now we find the crater, then we'll give you the an impact event took out the dinosaurs. Before that, it was climate change or it was volcanic eruptions or lots of different possibilities. There was the Alvarez team. It was a father and son team that found this like black rock layer, and they started testing the very bottom of that black rock layer, and they found really large concentration of iridium, which is it's a rare. It's not like a rare earth metal, but it's not found on Earth very often, but it's found in asteroids. And they started to check for this black mat around the world, and they were finding it, and they were finding very high levels of iridium all the way around the planet, which suggested that it was, a big impact that took out the dinosaurs. That
Mhm.
was the early 80s. We went almost 2 decades until they finally found the Chicxulub crater. And then the scientific consensus said, oh, okay, you guys got us. We'll give you the impact. That took out the dinosaurs. And now, every kid learns that an asteroid took out the dinosaurs. It's the same kind of story right now with the Younger Dryas, where there's a team, the Common Research Group, that is finding proxy evidence of an impact. They're finding a black mat layer in the soil. It's not rock yet. It's not like the Alvarez is finding that black rock layer.
Mhm.
But here we find like a black mat all the way across North America. Basically, what they did was they would go to Clovis sites. Are you aware of the
Wow.
Clovis?
Yeah, yeah, actually, yeah.
Yeah, yeah, yeah. So basically,
That's wild.
basically, yeah, the Clovis people are who get blamed for taking out all of the mega mammals in North America, which went extinct right around this same time. A lot of them did anyways, not all of them, but a lot of them kind of went extinct around the same time, 13,000 years ago. And so these guys would go to these Clovis sites, and they were testing the soil right at the boundary, and they were finding elevated levels of. In this case, it wasn't iridium, but they were finding elevated levels of platinum, which is another metal rare in Earth, but common in asteroids. They were finding more diamonds. They were finding spherules, like superheated carbon spherules, all across the United States at these Clovis sites. It was kind of their hack. Was they would go to well-known and dated Clovis sites and then check for proxy evidence for impacts, and they were finding it almost everywhere. Since then, we're finding it all across the world. Like they found it in South Africa, they found it in Russia, they found it. They're finding it everywhere in South America. They're finding this impact proxy of a cosmic event 13,000 years ago, and it's one of the reasons why the Carolina Bays always gets brought up with the Younger Dryas impact because that's possibly an explanation for how these two things formed. What they think happened now is that it wasn't a major impact; it was lots of bolide events. I don't know if you've ever seen a shooting star.
Yeah,
Yeah.
yeah.
Okay. Have you ever seen like a fireball, like a really massive shooting star?
I don't think so.
Yeah, they're pretty impressive. Like they blow up in the sky. It definitely catches your eye. If you
Yeah.
sometimes you can hear it. We had one go over my house a couple years ago, and it was a perfectly cloudless sky, and I was woken up with a really, really bright green flash, and then like a thundercloud, like it sounded like a thunder going off, but there
Hmm.
wasn't a cloud in the sky. It was actually the streak from a fireball and the explosion from the fireball itself. Um, Now they think that this was thousands and thousands of these explosions in the sky. If you ever get a chance to watch the Chelyabinsk, uh, which happened in Russia in 2012. It was a massive bolide event where an asteroid came in or a meteor came in, blew up in the atmosphere and shattered a bunch of glass, and the windows were falling on people, and like I think 1,400 people were injured.
Holy hell.
There's video of it.
Yeah,
It's
was
pretty
that the one in
impressive.
like 2012 or around
Yep,
there?
yep.
Holy shit. Yeah, that was
Yeah,
wild.
right. And so imagine like hundreds of those things or thousands of those things. Basically, we go through the path of an old comet, and when we go through this path of an old comet, normally we see shooting stars.
Hmm.
It's an asteroid. It's a meteor shower. We can plan for them. We know when we're going to pass through these things, and what they think was that we went through what would normally be a fairly common meteor shower, but instead of it being shooting stars, these were like massive chunks that were blowing up in the atmosphere and causing quite a bit of havoc, and they think that some did actually make it down to the ground, and literally it caused a tremendous amount of ice to melt from North America. There could have been some impacts into the ice sheet itself, and that's actually what triggered the Younger Dryas event to happen, and which is a very sudden reversal of the ice age, the warming of the ice age, because at the Younger Dryas boundary, we kind of flipped and went back into the ice age for 1,200 years. That's what the Younger Dryas is, and that's a scientific
Damn.
fact. Like this is something that's well known.
Yeah.
The cause of it is still questionable. We do know that there was a tremendous amount of fresh meltwater from North America that rushed into the North Atlantic, and kind of like put a squash on the Gulf Stream, and that's what kind of sent us back into an ice age of 1,200 years, and that's what caused like a lot of our mega mammals to go extinct and the Clovis people to lose their culture as well. So that all happened around 13,000 years ago. So, anyways, when it comes to these Carolina Bays, again, that 13,000 year timeline is very popular because we're trying to solve this problem as well.
Hmm.
Unfortunately, I think that they're two different things. I think they're two different problems, two different hypotheses, and I think that they're on two different timelines, in fact. Because the other probability is that these things are almost 800,000 years old, and that would put them well into the mid Pleistocene. There's a couple reasons why I think this is a more plausible explanation at this point. One is that we know there was a major impact. The Carolina Bays, if they were formed by an impact into an ice sheet, this would have been a big, big deal. It's like the Younger Dryas is kind of like a blip in the timeline, and
Hmm.
and we're having a hard time like finding enough evidence to to put the nail in that coffin.
Yeah.
If the Carolina Bays were formed by an impact, this would have been a major, major deal. And there was a major impact 786,000 years ago that created a chain of tektites. Are you familiar with what a tektite is?
No.
Yeah, so tektites they kind of look like meteorites,
Mhm.
but they originated from the Earth. So basically, they form after a massive impact where the ground is literally liquefied. It melts, gets launched into the atmosphere, and while it's in this air, it cools back down, solidifies, and you basically have like glass droplets raining down from the sky,
Damn.
falling onto the ground, and then we find them millions of years later or hundreds of thousands of years later.
Hmm.
And we do have a major tektite field all the way in Asia. The AA tektites, the Australia Asian tektites, are found pretty much on the opposite end of the Earth, and they don't know where they came from. They don't have an impact site. So, so we have a massive impact that took place 786,000 years ago that we don't have a crater for. We also have these Carolina Bays that we don't have a crater for. And the two very well could be connected, and we'll get into some of that here in just a minute. But
Yeah, are they shaped kind of similar to the Carolina Bays as Tektite sites?
not really. No, they just find these like glass. They're like solid glass meteorites.
Hmm.
And but you can like actually shine a strong enough light through them and see that it's like it's melted glass. It's pretty impressive. I have a couple of them, but I didn't bring them in here.
Holy
But
hell.
they are pretty fascinating. Yeah.
Yeah.
So we'll get into a little bit more about that, but that's not the reason why I think that the Carolina Bays were formed at that time. It's just
Hmm.
making the suggestion that we do have an impact that is still a mystery that
Yeah.
happened 786,000 years ago. We also have an impact 12,900 years ago, much more recent in our, to our own time, that we still don't have an answer to. And so we're just trying to connect the dots from these different events to see which one fits the best, and keeping that scientific process in mind as we're going through it. So, Antonio Zamora is one of the main proponents for a Younger Dryas impact event that created the Carolina Bays. He is using things like the Younger Dryas impact evidence, like the black mat layer, which
Hmm.
actually isn't a burn layer. A lot of people confuse that and they think that it's a burn layer. It's not what happened. It's actually like it's like an algal mat. Like the Younger Dryas got really cold for a really long time, and it was just like really cold and dank across the world. Where it really halted the growth of vegetation, and things just kind of got nasty and moldy, and it stayed like that for a long time. And that's what kind of formed that black mat. There's a picture of it right here. This is actually in Arizona, and you can see the black mat. But underneath that black mat, we find Clovis points, we find mega mammals, their bones, and but above it, nothing. It's like modern times above it.
Hmm.
So something happened right there at that time. The very large spike in platinum is kind of really important. We also find shocked fractured quartz now, which is more of a recent find. There's a 10% biomass burn that took place at that time, and also a major Y chromosome bottleneck, which happened 13,000 years ago. It's a lot of people don't know about, but it may lead to some of those tribes of the Amazon, the women tribes. Add some plausibility to those stories.
Interesting. Yeah.
Yeah. We also have a mega mammal mass extinction, which we just talked about, and that Clovis culture collapse. So one of the things that Antonio uses for, it's kind of his smoking gun, is that some of these Carolina Bays that have been tested for Clovis site occupation, they do what's it called? OSL dating. It's optically stimulated luminescence dating, where they go down in a column. The column is up and down, but the samples have to be taken horizontally. And so they take these horizontal samples in complete darkness, and they have to keep them dark until they can actually test them in the lab to see when the last time those grains of sand were exposed to sunlight, which they can do, which is pretty impressive. And
Wow.
that's where they get a lot of the dating from is actually dating those sand grains from the last time that they were exposed to daylight. And in the past, they've used these dates for identifying formation times for the Carolina Bays. I think that they're dating like erosion events. And if you have a lot of wind, because they're always dating the rims of the Carolina Bays. The rims are exposed to wind, and they're exposed to the environmental conditions.
Yeah.
It's probably the worst place to get dating evidence but that's not their purpose. Wasn't for formation of Carolina Bays. Their purpose was for dating Clovis sites, and that's what they were using it for.
Gotcha.
But they find inverted stratigraphy where they start from the surface and they go down. It gets older and older and older, and then it flips, becomes younger, and then becomes older again. So they basically, what Antonio is suggesting is that at the time, that's when the Carolina Bays were created, and the rims were flopped over, and that was what gives them that inverted stratigraphy. I argue that, well, if the wind is blowing at night, then it's not going to lock in those newer dates, and so that's why we get inverted stratigraphy, is because wind doesn't stop blowing at nighttime. It continues to,
Very
continues to
true.
blow.
Yeah.
Right, right. So I don't find that to be a very plausible explanation, but that's his smoking gun evidence is that we have inverted stratigraphy, at least at two sites that they tested. This is an image of that inverted stratigraphy where you see they dated at 5,000 years, 9,000, 9.2, 11.5 thousand years, and then it jumps way back into 15.5 thousand years, and then 13.1 thousand years, which is around that Younger Dryas time frame.
Hmm.
Again, I suggest that these are erosional events, and most people would agree that the Younger Dryas boundary was a major erosional event. It was we were basically getting rocked back into an ice age, and there would have been really serious erosion taking place at that time. But like I said, any erosion that took place at night wouldn't lock in the OSL dates. It wouldn't lock in the last time that sunlight was exposed, if that makes sense.
Hmm.
The other time frame goes way back. This goes back into the mid Pleistocene. Again, I think this is more of a accurate time frame. Uh, Not this is something that these guys, Michael Davis, who we talked about a minute ago, he's the one who's kind of responsible for the lidar that we use now. His research partner Thomas Harris or Tim Harris. Tim is actually he worked for Lockheed Martin and Boeing.
Dang.
He's a mechanical engineer, and he worked on some of their not aerospace stuff, but he worked on some of their aviation equipment. Back in the day, that the AA tektites that we were discussing actually originated from Michigan, and he can back that with physics, which is pretty impressive. Um, Another thing to point out is that where we find most of these AA tektites is the antipod of Michigan. An antipod is like the exact opposite end of the earth. If there was a major impact, and I think that for the Carolina Bays to be formed in this way, that it would have been a major deal. That the impacts could have been launched to the other side of the planet.
Holy hell.
Um, Again, do you remember the gravitational anomaly? Pretty much matches the Chicxulub event, which is the dinosaur killer.
Hmm.
I think that this event was on par with that. I think that it was a major deal. The biggest difference, though, is that instead of an asteroid hitting a shallow sea, which took out the dinosaurs, the impact hit a couple miles of ice, and the ice absorbed most of that impact. The result was the ice being launched and creating the Carolina Bays. The impact that actually went into the ground, into the sandstones, chemically matches the AA tektites. They actually are able to chemically match that to sandstones of a certain age, which happens to be the missing sandstones of Michigan, the Michigan Basin.
Dang.
Yeah, there's like a lot of boxes being checked
Yeah.
with this much older timeline. The problem is that it's so much older. Most people hear that and they're like, "Ugh, they can't. There's no way Carolina Bays could be that old. That these sandy ellipses can be 786,000 years." But we'll discuss in a minute why I think they can be.
Hmm.
But again, this is just the other time frame. We also find mass extinction events taking place around 786,000 years ago. It's called the mid-Pleistocene transition event. We basically have a shift in Milankovitch cycles that took place then. I'm not sure if you're familiar with the Milankovitch cycles, but it's basically what takes us in and out of ice ages.
Gotcha.
We
Is that
used
pole
to have,
shift?
yeah, well, there was a major pull shift. That was the last major pull shift that we had. Occurred around 786,000 years. It's all
Damn.
the same
Yeah.
time frame, all the
Do you
same
think
time
the
frame.
impact could have caused the pole shift or
I think it could have been the final, the nail in the coffin that caused it to swap. Yeah.
gotcha?
Yep.
Holy
Yep.
hell. Yeah.
Yeah. I mean, we literally were going in and out of ice ages every 41,000 years before this event, and after it, they were 100,000 year cycles. So something happened. Something happened, and I think that it was this impact event. I think that it was an impact, a primary impact into an ice sheet over Michigan. It launched the melted sandstones into the atmosphere. They came crashing back down on the other side of the planet to create the A-tektites. The ice that was launched was lifted and launched. They came back down in Nebraska, what's now Nebraska and the east coast of the U.S. This is also the time frame that we see in the historical record a split of Homo sapiens and Neanderthals from a common ancestor. So usually you don't see major like evolutionary splits like this unless something major happens to cause the speciation or cause the division of genetic lines.
Hmm.
And this impact could do it. This impact could have caused a major stress, major extinction event. I think we see like a 99% genetic bottleneck 800,000 years ago for Homo sapiens, again, our own species.
Hmm.
And again, this was the division of what led us to us and what led the Neanderthals down their path and eventual extinction. So again, it's fascinating, but it does go very far back, 800,000
Yeah.
years. Geologically, that's not that long ago. Again, geologically speaking, remember the Earth is 4.5 billion years old. So,
Hmm.
geologically, 800,000 years is nothing. But for us, it's everything. So,
Yeah.
yeah, it goes
That's
pretty far back.
fascinating.
Yeah. I already mentioned the ice core data. That's where we get a lot of this from, is the ice cores. Now, the reason why I'm leaning towards a older explanation now, and it kind of sucks because when I used to think that it was Younger Dryas, like that's our recent history. Like that's when we decided we weren't going to be cavemen anymore. And instead, we were going to start like agriculture, and that's what like led us to our current, present. And but it was actually a conversation that I had with Tim Harris one night that kind of really made me change my mind. And no, actually, it wasn't Tim Harris because Tim Harris got me kind of scratching my head because he was the one who brought up the tektites and actually using the physics to back up where the tektites are found and how they originated from Michigan. But I wasn't convinced at the time yet. It was a conversation that I had with Michael Davies, who was we were arguing about Carolina Bays because again, he's always been very adamant that these things are very old, like 800,000 years old. And
Hmm.
at the time, I was pretty adamant that they were Younger Dryas in age. And he was telling me about how pool table flat these Carolina Bays are. But if
So the bottoms are flat?
yeah, the bottoms are like super flat. But what he was
Oh,
telling me
wow.
was that basically the coastal plain, like from the fall line all the way to the beach, is pool table flat.
Mm,
And I was
okay.
like, Michael, that's not true. I live on the coast, and we have old ancient barrier islands where there's like the ecology is completely different and everything. We call them sandhills. And I was like, here, let me show you. And I went to go, like my arrogance, I went and pulled up his LiDAR to kind of prove him wrong. But when I did that, I actually noticed something that was really kind of eye-opening. And I don't know why I didn't notice it before. I kind of think I did, but I was creating excuses. I was coming up with ways
Hmm.
to kind of like, straw man my own arguments. And and it's kind of frustrating because it's so obvious when you see it. But this image, this Google Earth image, is of a field trip guide that was done by Valdosta State University, actually my alma mater, and
Hmm.
they would actually go to the beach on Sapelo Island, which is a barrier island, and they would investigate the sand dunes and things like that there. Then they would take the ferry back across, they would get on a bus, and they would stop at these different spots that were old barrier islands and investigate the similarities between the different places and basically the timeline going back in time. And that's what this image is showing you here. So when I went to go pull this up, I clicked on the LiDAR, and that's where I saw like where the Carolina Bays could be found. All of those red dots are Carolina Bays that Michael Davies has marked and put into his Carolina Bay survey or the Ovoid Basin survey now.
Hmm.
And it's really where you don't see them that I found so shocking is you do not find them below those barrier islands.
Gotcha.
Yeah, yeah, yeah. So if this happened 13,000 years ago, if it happened at the end of the last ice age, if they were formed by an impact, we should see it all the way to the beach. All of this is land now. All of this is dry land, with the exception of some of the marshes and things like that. But when you click in that LiDAR, you see you only find the Carolina Bays on top of those old sandhills, on top of the ancient barrier islands that were formed hundreds of thousands of years ago.
Hmm.
And to me, instantly, I mean, it was like somebody punched me right in the stomach. There's no way that these things could be 13,000 years old, that they have to be older. They have to be. And when I started to investigate, well, then when were these barrier islands formed? That pushes that time frame back 125,000 years ago. That was the last interglacial that we had. Sea levels were higher then. Sea levels were like 30 feet higher 125,000 years ago during the last interglacial. We're in an interglacial right now, right? We're in nice warm temperatures. We can grow food for 8.2 billion people. The last
Yeah.
time temperatures were like they were today was 125,000 years ago. We literally have an entire glaciation of North America in between where we were in the depths of an ice age.
Hmm.
Sea levels were 400 feet farther away. Sea levels were, no, I'm sorry, 400 feet lower than they are today, and like 100 miles. Where this beach is, where this Sapelo Island is,
Hmm.
that beach would be 100 miles further away during the peak of the last ice age. This whole entire area hasn't seen, the current sea level until really around 6,000 years ago.
So you're saying that area has like sunken in since?
No, the ocean has receded and come back in, right?
Okay,
So
gotcha.
right now, like we're in the middle of an interglacial. The ice caps have melted. They filled into the oceans. The oceans have risen up 400 feet, and
Hmm.
we can go to the beach today and see
Damn.
the constant wave action of the beach.
Hmm.
If we go back 20,000 years ago, it was 100 miles farther away and 400 feet lower. All of this
Oh,
that's now ocean water was high and dry exposed land at the time of the Younger Dryas. And we
damn.
should see Carolina bays everywhere, everywhere on this image, but we only see them in the old, which basically tells me that these Carolina bays were here the last time the sea levels rose and scoured the ground and then receded. And then they came back up to where we are today. Not only do I think that they're older than 125,000 years ago, but I think that there's evidence that suggests that they are older than 400,000 years ago, which is the time before that, where sea levels were higher than then. They were 42 feet higher. And there's evidence of that. Just making the suggestion that they have to be older than 400,000 years ago, it just makes them really old. It sucks because the Younger Dryas was really sexy. It was fun. I
Yeah,
had a
people love
lot
talking about it.
they love talking about it, right?
Mhm.
Come. So, anyways, here we have an image of Myrtle Beach. You can kind of see the processes happening here. When you click on the LiDAR, you can see where the Carolina bays are
Hmm.
and where they're not. And this is because the oceans have risen and then receded and risen again a couple times since then. And you can see where the really good Carolina bays are. There are also Carolina bays that are like truncated in half in this area,
Yeah.
which is very suggestive that they were full. They had to have been fully formed Carolina bays that have been eroded away. And it doesn't matter. This is the best part about this is it doesn't matter how they were formed. If it was wind and water or impacts, the age suggests that they were eroded at some time in the past, which really, should end the whole Aeolian lacustrine debate over the last, couple 100,000 years, or not really the past 100,000 years, because this
Hmm.
makes them far older than those. So that should help with that debate, regardless.
Yeah, it's really cool.
Um,
I've been to
we
Myrtle
find this
Beach
in
quite
it.
a bit. I
Yeah,
had
yeah.
never known
A
that.
lot of people have. Yeah, a lot of people have. This is prime time beach community.
Yeah.
There's golf courses, there's, water parks, everything that you want, all right in one compact location. But you click on that LiDAR, it strips all that stuff away, and you see the ground, and you see where those Carolina bays are and where they're not. And it really helps with the whole timeline. In my case,
Hmm.
this to me is the best way to probably date these Carolina bays, is to use those old barrier islands and go way back into time.
Yeah,
Again, we
definitely
see it in
understand.
other, yeah, we see it in other places like Oak Island and St. James. Again, this is just a little bit farther up the beach. But when you click on that LiDAR, you can definitely see that there's a transition area between where Carolina bays are and where they're not. And we see really well formed Carolina bays on the highest locations.
Hmm.
Hopefully the color coding, this, does it confuse you a little bit, or do you kind of get the color code?
No, I get it. Yeah.
Like this area, it goes from the lowest at the beach and then it goes up and then back down,
Hmm.
because it's kind of like an old Bear Island. There's a major river basin back there, floodplain. I think it's the Waccamaw River Basin. But regardless, you can see where those Carolina bays are. They're only in the very highest locations, and there's nothing in this area. Again, it's all high and dry now. There's cities there. There's a whole neighborhood of people
Hmm.
that live in this area, a whole beach community. But no Carolina bays. It was all underwater 125,000 years ago and 400,000 years ago. And then before that would have been like over a million years ago. So it had to have been formed sometime between 400,000 years and a million years. And that 800,000 years, 786,000 year time frame falls right in that window.
Yeah.
Camp Lejeune, pretty well known for our marine communities. Marine, the service members spent a
Hmm.
lot of time at Camp Lejeune. Here's an artillery range, like right in the middle of the page. You can see right in the middle where that artillery range is a perfectly truncated in half Carolina Bay, where the sea levels rose, washed away half of it.
Hmm.
Basically, the seaward side got eroded away, the windward side, but the leeward side, you still see it. It is still there. And there's more of those examples in that location as well. So that's why I think that these Carolina Bays, are a lot older now. There are some exceptions to the rule. Here we have like the Delmarva Peninsula, not very far away from Maryland, where you're from.
Hmm.
Did you ever spend any time in the Delmarva Peninsula? Yeah.
I don't think so.
Well, here we have there's like a main ridge where the highway system is built.
Yeah.
That main ridge is covered in Carolina bays, but on both sides of it, they've been eroded away. They're not there anymore. This
Hmm.
area is actually sinking. You were asking about sinking land a minute ago.
Yeah.
This area is subsiding, which means that it is slowly sinking. So we actually find Carolina bays here lower than we should. But if the ground is sinking, then that makes more sense,
Yeah.
that we would find them there. Like you can see a series of Carolina bays that are in this red over here. That whole area was actually higher in the past and has been sinking down, which I think adds more credibility to these things being far older, like 800,000 years old. And when you go back in time, that amount of subsidence definitely does affect the locations. We also see areas where it's slowly rising, like Charleston, South Carolina. It's slowly rising, and that's why we have like earthquake activity around Charleston. But here we have locations where they would have been lower and exposed to ocean water, and now they're higher. So we don't see those Carolina bays in those locations until you start getting into some of these other areas where you find those Carolina bays.
Hmm.
So that pretty much tells the story. I already talked about the wind and water hypothesis. This is why, this is what they currently are using as the explanation for Carolina bays. Almost all of these people will readily admit that it's still a mystery, though. Like this is their best guess, their best hypothesis. The problem that I've seen is that they aren't following through with the hypothesis. Like they haven't tested it. It actually everything goes back to 1977. There was a guy, he was working on his PhD. It's not even a peer-reviewed paper. It was a PhD dissertation paper, where he was trying to prove that Carolina Bays were oriented lakes. And to prove it, he set up a sand table and repositioned a fan every 15 minutes. He turned it 180 degrees every 15 minutes for 4 hours. And the shape that he got, he didn't even take a. This was 1977, but he didn't even
Hmm.
take a picture of his results. He did like a hand drawing, and even the hand drawing isn't anywhere close to what a Carolina Bay looks like. And he started from a circular depression. He literally went into the sand, dug out a circular shaped depression, which in my opinion, that's the definition of what a crater is. So he literally started with a crater and then blew the wind from the fan across it every 15 minutes for 4 hours. And he got this like wonky football shape. It's not even close, but that's the like everything goes back to that. Like all the
That's
current
crazy.
explanations for Carolina Bays goes back to this 1970. In fact, this guy, Christopher Moore, he's one of the head researchers for the Comet Research Group.
Hmm.
He actually has a poster board titled, yeah, it's right there, it's on the page. Kazaworski was right. And so in 2012, he presented this presentation using LiDAR and everything that I've been talking about to say that Ray Kazaworski's 1977 dissertation paper was correct, that wind and water created the Carolina Bays. And that's, I mean, it's just so far from what I think happened. And
Yeah, I mean that test seems extremely flawed, especially if you're
yeah,
like digging a hole first and then doing the fan method,
yeah.
and it's still not even resulting in the same shape of the bays.
Exactly, exactly. And it should be replicable, right? We should be able
Yeah,
to do it. Anybody should be able to actually go out there and set up the same experiment and create Carolina Bays. It has never been done. It has never, ever been done.
yeah, that is
But
extremely lazy.
yes, but you and I, we can go to the beach today and we can create Carolina Bays in seconds. In seconds. Matter of fact, I'm gonna skip forward a little bit.
Hmm.
If you go to the beach and you kick water from the sand, it creates perfectly elliptical shaped depressions. They're just scale invariant. They're a lot smaller.
Hmm.
I had a lot in this presentation. Golly, um, we won't go over all
Yeah,
this.
they're everywhere. I mean that's
Yeah,
really, really crazy. Like how it's just like so unknown like that for the
yeah,
most
yeah.
part.
Well, and I had a lot of examples too. A lot of examples of some. One of the problems is that when they say that they're wind and water, and they tend to like point at examples like the
Hmm.
thermokarst lakes that we find up in Alaska, like in the Arctic Circle. And I literally like just this summer had this like major argument discussion with some of the members of the Comet Research Group that are highly against Carolina Bays being impact related because they're trying to prove their own impact, right? And the Carolina Bays just kind of keep getting brought up, and so it gets them very frustrated, and then they get frustrated at me, and I'm like, well, you follow the science, guys. You're not doing
Yeah.
that when it comes to these Carolina Bays. And if you're not doing it for the Carolina Bays, then how can I take you seriously with the Younger Dryas work that you're doing? Which and I actually agree with them on that stuff. I think that they're
Hmm.
actually doing really good work, but they were really nasty about these Carolina Bays. But like I said, I can go to the beach right now and kick water onto the sand, and it will create perfectly elliptical shaped depressions over and over and over again, with raised sandy rims and orientation going right back to where I kicked that water from. Same thing with the Carolina Bays. They have all of those imprints that go right back to the source, which happens to be Michigan. The Great Lakes region of Michigan.
Yeah, so what would you think would cause like that similar? Because those are like almost exactly the same orientation and
Yeah.
shape as the bays. Would that be something like really hot, like plasma or some kind of melted, I don't know what to say, like
Well,
rock or something, like landing on Earth to kind of form
so I
that?
think the impact. So I think the impact happened into an ice sheet, and it was the ejected ice from the impact. Now you
Hmm.
mentioned plasma. I don't. Plasma is just the fourth phase of matter, right?
Hmm.
So we have solid, liquid, gas, and then we have plasma. It very well could be that the energy related to this impact was so great that it caused the ice to bolide or to turn into a toroidal shape, and
Hmm.
that's what impacted the Earth. That's very well possible. That could be what happened. I don't think it's necessary to
Yeah.
explain the Carolina Bays. I think that, the fact that these things probably exploded before impact is probably a pretty good suggestion. And
Hmm.
in fact, I recently had a PhD physicist contact me and was very adamant that he agreed with almost everything that we had to say about these Carolina Bays, with the exception of them being solid impactors. He thinks that these things, he's a fluid dynamic physicist, and he
Hmm.
models fluid dynamics for certain situations. I can't remember. He was explaining to me what he was currently working on, but that's what he does for a job. But he does computer modeling, and he modeled this impact, and it basically shows that these things would not have survived as full solid impactors. I already kind of suggested that they wouldn't be solid anyways. That the way that glaciers form, it's
Hmm.
basically layers of ice, and that this they would have been highly fractured conglomerates of solid ice, which would have increased the chances of them blowing up. Basically becoming bolides before they make contact with the Earth, and that's what caused them to be so shallow. You don't.
Gotcha.
He was saying that if this was solid impactors, that the shapes and the depths would be different. And I kind of agree with him. I said, yeah, that does make a lot
Hmm.
of sense. And that, in fact, that these would have to have been bolides, the ice would have blown up and created those elliptical, flat-shaped depressions. Again, the science is still out there. The science it has to catch up.
Yeah.
And right now, when we're still arguing whether or not ponded water could do this, thousands and thousands of times, it's really it's hurting progress. It's hurting the progress there.
Yeah.
So
So they say the impact possibly or probably happened in Michigan. Is that anything to do with the creation of those lakes, or is that
you
nothing
know,
to do with
I
it?
I'm not taking it off the table. I think that there's a whole lot of geology that is being misled right now, and once we start to connect the dots and suggest, that hey, there was a major impact, like on par with the Chicxulub crater, then that puts that right on the table. That the Great Lakes themselves could have been a secondary effect of this impact. I think it was a big deal. We're talking like the dinosaur killer was like an 11 kilometer, somewhere between 9 to 11 kilometers, which is the size of a small city.
Hmm.
It
Damn.
wasn't minor,
Yeah.
and I think that this would have been around that same scale. I mean, this would have been a big deal, and to cause melted sandstone to launch to the other side of the planet, and for the Carolina Bays, 1,500 kilometers away. These things aren't small. I mean, we looked at a ton of examples. These things are,
Yeah.
1 to 2 kilometers a piece. They're not tiny. They can be smaller. There are some smaller ones, but most of them are huge. You drive in and out of them, and you're down there for a while before you come out the other side. So, you know,
Yeah. What do you
big
think the
deal.
main the main like science that's not really being allowed to come to light with some of these, or I guess being hidden,
I don't know.
or just being like written off, like we're not allowed to look into, I guess, the lakes or kind of pull from
Yeah,
that
I mean, because I
information.
presented like enough evidence, I think that like any geologist should at least re-examine them, right? And
Yeah.
that's still not happening. And a lot of times it just gets like waved like, oh, we already kind of figured this out back in the 70s. It's not that big of a deal. And I'm like, no, it's kind of a big deal. It's a big deal that you guys did not follow the scientific method. It still hasn't been followed. And all I'm asking you to do is to reevaluate a few things, and that really hasn't happened. And now I do right now, my biggest critics are members of the Comet Research Group, which is kind of hilarious because they're pushing for their own impact event, right? They're pushing for a Younger
Yeah.
Dryas impact event. And I can understand now why they get so irritated whenever Carolina Bays are brought up. Because forever, people have been connecting Carolina Bays with the Younger Dryas. I did it for years.
Hmm.
And it wasn't until like a couple, 4 or 5 years ago where I finally had to be like, no, no, there's no way they're connected, and they need to be treated differently. By separating the two hypotheses, I really do think that it strengthens both of them. Like I really do
Yeah.
think that if you can say that, hey, they're both impact related, but they're two different impacts, it adds so much strength to both hypotheses. But these Common Research Group members would rather them not being brought up at all. Like
Yeah,
literally,
that's what I was gonna ask.
yeah.
Like, are they trying to claim those impact sites for themselves, or like why are they like upset that
No,
you're kind of
I
bringing
think
that
they're
up?
upset because well, it's muddying their water. Like they want to solve their problem. They want to solve the Younger Dryas problem. To them,
Hmm.
it's clear that these Carolina Bays are not Younger Dryas in age. That's not saying that they're not impact related, but they want to remove them completely. Like they're just like, get them out of my face. I don't want to see them. Let's not
Yeah,
talk
that's
about them.
why. Doesn't make any
But
sense if it doesn't like affect their theory or timeline.
It has though for so long
Oh,
that
gotcha.
whenever they
Okay.
hear it, they're like, "Oh God, here's the Carolina Bays again," and then they
Yeah.
get upset. Like I literally had like a phone call from one of these guys that was like, "Wait, why were you talking about Carolina Bays at the Cosmic Summit this summer? I thought this has already been settled, business." And it's like, no, it's not. That's why I'm talking about them still, you know. And he was really upset that led into a whole email chain of, that included people like Graham Hancock and all kinds of stuff. And I'm like, what is going
Holy
on
cow.
here?
Yeah.
Yeah. Like it got a seriously heated debate about Carolina Bays, and like I literally had to take the evidence because he was basically showboating. He's one of these, he's been doing it for a long time and he's old, and most of these guys are going to age out, over the next next decade or so. And
Yeah.
unfortunately, that's kind of how science changes. You've probably heard that science changes one funeral at a time, and I feel like we're in a time where that doesn't have to be the case. Like we can
Yeah.
present enough evidence to make you help, this hypothesis, but instead they chose to be, kind of buttholes about it.
Well, yeah, I
So
think there needs to be like minds like yours where you're able to shift um, your thought process based on
I
new
can,
information like you did, you know?
yeah,
Like if you're so
yeah,
hard-headed on one theory, you're unable to look into, evidence around other
well,
eras of time. I just, yeah, it kind of blows
yeah.
my mind. And in a way, it kind of discredits, I guess, that person. Like,
Well, and it's
unfortunately,
unfortunate
yeah.
because yes, exactly, and maybe that's what it takes is that science teacher that keeps bothering us, he's the only one that's actually following the scientific method and reevaluating based on evidence that was presented and actually changed his mind. I'm the only one that I know of that has changed their mind. Even Antonio Zamora and Michael Davis, they have two completely different time frames. They pretty much agree about nothing, except that there was an impact into Michigan at some time in the past. That's like
Yeah.
their only agreement, and I can't get them to change their mind about anything. So I
Dang,
don't
yeah,
know,
that's
but
wild.
I think it's
What
important.
what's the craziest theory you've heard on this?
The craziest theory I heard, and I feel kind of bad for her. It was at the very first Cosmic Summit, which was. Are you familiar with the Cosmic Summit at all?
Somewhat, yeah, I've heard you mention it a bunch. It sounds
Yeah,
pretty interesting. Do they have them all around, or is
yeah,
it
yeah.
just one spot?
No, no. Well, so we've had three of them so far. The first one was in Asheville, North Carolina, and then the
Mm-hmm.
last two were in Greensboro, North Carolina.
Oh, cool.
Anyways, it's just a collection of a bunch of like interesting topics. So most of them focus around the Younger Dryas, right?
Mm-hmm.
And that's kind of what I got the invite was because I was at one time focusing on the Younger Dryas,
Yeah.
and then here I come, I walk up on stage and be like, yeah, I don't think it was the Younger Dryas.
Yeah, you probably
Oh,
ruined some days right there. Some people's
yeah,
lunch.
yeah, I'm all of a sudden like the most unpopular person there, but whatever, I don't
Dang.
care. It's not
Yeah.
about popularity. So,
Mm-hmm.
anyways, one of the ladies there, she raised her hand and actually she got in line and like in front of the whole audience, asked if Carolina Bays were possibly the Anunnaki craft landing pads, and everybody was like, "What? What?" But everyone was very kind. It was a
Yeah.
good
Sorry.
audience.
What kind
So
of landing craft pads?
the Anunnaki, the
Oh,
uh,
Anunnaki.
the the, the
Wow.
Watchers, yes, the
Yeah.
Watchers
Ooh,
coming down in their spaceships, and they needed landing pads. So that's what they.
70,000 of them. Yeah, that's the
Yeah, it's
one
a
thing
lot
that
of.
it's like you have to take in consideration how many of them there are. I mean, it
Yeah,
really,
well, and if you look at Wikipedia, it says there's like 500,000 of them.
damn.
Um,
They're just
Wikipedia
labeling
is
like
pretty
wrong.
terrible.
Yeah.
It's
Yeah.
wrong about almost everything,
Yeah.
and as far as Carolina Bays are concerned. So actually, it would help us if there was like 500,000 of them, but there we have literally like Michael Davis says more 70,000 of these features, and there's more out there that he hasn't marked for sure.
Yeah,
So
it's based off that LiDAR website you said. What is that again?
it's cintos.org,
Cintas.org.
CINTOS
Mm-hmm.
.org. Yep, you can go on there as long as you have Google Earth Pro. which is the downloadable edition for your laptop. It's free. It doesn't cost anything. And then you go to centos.org and click on his download for the LiDAR. He has the entire continental United States LiDAR now. When I first met him, he only had a couple of states like North and South Carolina, and he
Hmm.
started adding more and more and more. And now he has like from coast to coast, California to the Carolinas, completely covered in LiDAR, which makes it so interesting to look up anything. Where the
Yeah.
area that you are, you're talking about those Clovis sites. You
Yeah,
can
that's
you
what I was about
can
to ask. Like, would it
yeah, you
show
can
like
use
mounds?
yeah, if
Yeah.
there's an elevation change, it's going to show them. Um,
Interesting.
the only place it's really good when you're looking at super flat land. If you're in a really hilly location or mountainous area, it's pretty worthless
Yeah.
because the terrain changes so sudden that it's like color changes. It doesn't help very much. It
Yeah.
actually helps to go back to grayscale for that, but really flat land, you can see. I've been able to identify Indian burial mounds at sites that are undocumented.
Wow.
There's all kinds of cool stuff.
That's
Yeah.
really cool.
Yeah.
Well, man, I really appreciate your time and really appreciate your insight on all this. I ask every guest at the end of the show the same question, and I guess I'll ask you because I really appreciate your scientific background and thought
Mhm.
process on everything. What do you think happens to us when we die?
So yeah, I was expecting you to ask this question today too. First thing, I don't think that they're exclusive. I don't think science and having faith are two separate things. I think that they're together. I think, we just have to find a better way
Hmm.
to investigate them, together. And I do think that we have a soul, and I do think that that soul has been here and it will continue on after our bodies are done with it, and or I guess I should say, our souls are done with our bodies.
Yeah,
It'll move on. So that's what I think happens
interesting, man.
yeah, after death. So
Yeah, well,
yep.
dude, thank you so much. Where can people find you and your work online?
So I do have a, YouTube channel. I'm not quite as active as I used to be. I've been writing those scientific papers, and I'm currently working on a book to kind of like put all this stuff together. But I do have a YouTube channel. It's the Dabbler's Den. You can find me at Chris at Dabbler's Den on Twitter or X. I have just basic accounts like that.
Yeah.
But yeah, yep,
Well,
yep.
well, very cool, man. Well, thank you so much for your time. I really, really appreciate it.
Yes, sir. Good luck with your music and everything else too.
Mhm.